This video is designed to show you the kinds of notes that you could be writing in your book to consolidate your learning. Now, you may have written notes already from the board. As we've been explaining things, you may have taken your own notes. That's absolutely fine. But this gives you an additional opportunity to make sure that you've got something written down in your book to help you learn if that's the way that you want to learn during the course of this year. So, the key ideas that we've had a look at this year are basically how to interpret the periodic table and to look at things like the numbers of protons, the number of neutrons, the number of electrons. We've made a video that goes through all of that for grade 9, and it's probably best at the moment to save repeating all of that for this video if you just look at, so I'll just write down the top here, just look at the video, so go back onto YouTube and have a look at the video for grade 9, and then we'll add the extra stuff underneath that. So there may be stuff that you want to write down from the grade 9 video, which is very relevant to grade 10 video. So its name is going to be Science Grade 9 Chemistry Week 1, and it's going to be called Key Notes is going to be the name of it. So go and have a look at that first, get the information there written down, and then now, when you've done that, this is the extra stuff we need to have a look at for grade 10, which is the Bohr model. So with the Bohr model, the idea is that the electrons are in orbits or shells. Shells is kind of a better word because it reflects the idea that the electrons are actually in three-dimensional space. If you think of them in an orbit, you think it like Jupiter or Saturn moving around, which is only moving around in two-dimensional space, but they're actually in three-dimensional space. Normally when we draw diagrams, we draw them always as flat diagrams, but they aren't flat diagrams. Atoms are actually three-dimensional objects, and some atoms actually do have a very spherical shape. Okay, now the basic idea is that there is a filling order, so the shell filling order is the first shell, which is the K shell, fits 2 electrons. The next shell, the L shell, so the second, which is the L shell, fits 8. The third, which is the KLM shell, fits 18 electrons, but you start filling the N shell after 8. Don't wait for the full 18 to get there. And that explains why the periodic table has more stuff on the left-hand side than the right-hand side than the middle. Okay, that strange filling order, slightly weird. Okay, let's move that up a bit. Up you go. And then after that, we have the next shell. If you're curious, the fourth, the N shell, fits 32. And the final shell, by the way, we won't really worry about the O shell or any of the other shells that are higher this year. The O shell fits 50. as an aside, mathematically minded people might have realised what's the sort of pattern between 2, 8, 18, 32 and 50, and a pattern mathematically speaking, so just as kind of a side note, the nth shell fits. It goes up actually by working out n squared and then doubling it. So for example, 2 times 1 squared is 2, 2 times 2 squared is 8, 2 times 3 squared is 18, fits 2n squared electrons. So for those of you who like a bit of algebra, that's the actual rule. So that's where these numbers 2, 8, 18, 32 and 50 came from. Okay. Move this all up. How are we going? So all we really need to now do is to look at hydrogen. Sorry, not hydrogen. So looking at fluorine, which was the example that you saw on the end of the grade 9 video. At fluorine, if we're scattering this out, we're not going to draw it randomly. There'll be some method to the madness. Inside fluorine, I'm just going to move this up some more. So I've got some space, move all of this up. Inside fluorine, we've got our nucleus, and this is the same as on the grade 9 video. I'm going to put in 3, 4, 5, 6, 7, 8, 9. I'm going to fit 10 of these neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then when it comes to the electrons, there will be 9 electrons to put. And therefore, I start with my first shell, which is the K shell. So I'll draw my 2 electrons. I'm going to draw a dotted line around the shell, so you can see that it sort of goes in an orbit. But remember, it's really a 3-dimensional thing, not a 2-dimensional thing. It's a bit like peeling an onion and seeing the layers in an onion. And then finally, I've got 7 more to do. So that's why the next 7 are going to be in this area. So now we're going beyond what you did in grade 9, or what most students are going to do in grade 9 this year. 1, 2, 3, 4, 5. I've got 2 more to go. I think 1, 2, 3, 4, 5, 6, 7. So this is the Bohr model. So this is the Bohr model. So it's not just electrons scattered randomly, they're in 2 distinct orbits. We've got 2 in the K shell, 7 in the L shell, and overall we've got 9. And we just might like to write ourselves a reminder for fluorine that the number of protons, although you may have written this down previously, number of protons, behave yourself, pen. So double check equals 9, number of electrons equals 9. The number of neutrons I apologise for this, I haven't written it very well. Equals 10. And let's do a double check by doing a bit of counting. We haven't made an error. 1, 2, 3, 4, 5, 6, 7, 8, 9 for the number of protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we recount that. I might have only drawn 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10. 10 neutrons and the electrons. 2 in the K shell. 1, 2. And then the last 7 are in the L shell. 1, 2, 3, 4, 5, 6, 7. That's all done. I think that together with your grade 9 notes should give you a sufficient amount to write down in your book, and you'll be able to look at the beyond core and accomplished levels by reading the other information or watching the other videos that have been provided for you. Thank you.